Good day, dear friends. Hope all of you are fine. I'm Pranasish. I'm here to tell you whether we get some information about the acceleration of a particle in the position time graph for the rectilinear motion of the particle. In the last video, we got to learn how the velocity changes at different points along the same straight line or curve obtained in the position time graph corresponding to the rectilinear motion of a particle. Here we have three straight lines obtained in the position time graph. The first straight line is parallel to the time axis, and we know that if the straight line is parallel to the time axis, it means that the particle is at rest and its velocity is 0. Hence, the acceleration is 0. This straight line indicates that the velocity is positive but constant. Hence, the acceleration is 0. This straight line indicates that the velocity is negative but constant. Hence, the acceleration is again 0. So, when we get a straight line in the position time graph corresponding to the rectilinear motion of a particle, we can say that the acceleration of the particle is 0. Since the acceleration of a particle is the change in the velocity upon the interval over which the change of the velocity takes place, and the instantaneous rate of change of the velocity of a particle is the instantaneous acceleration of the particle. Now here we get two curves. Both the curves are directed upward. It means that the velocity is positive. Along this curve we see that the slope of the tangent increases as the time advances. Hence, the velocity increases, and so the acceleration is positive according to this curve obtained in this position time graph. Those who went through the last video can easily say that according to this graph, the velocity is positive but decreases as the slope of the tangent decreases as the time advances. Since the velocity decreases as the time advances, we can say that the acceleration is negative according to this curve obtained in this position time graph. We get two more curves here. Both of these curves are directed downward, and it means that the velocity according to this curve and this curve is negative. Here we see that the slope of the tangent increases as the time advances. Hence, the velocity increases in the positive direction. However, the tangent here is steeper than the tangent here. So, we can say that the tangent becomes flatter as the time advances. So, the magnitude of the velocity decreases according to this curve, though the velocity increases in the positive direction. Hence, we can say that the acceleration according to this curve in the position time graph is positive. Now, let's move to this curve. Let's draw here a tangent directed upward, and this is the angle that the tangent makes with the positive time axis. And let's draw another tangent here, and it makes this angle with the positive time axis. Here we see that the angle that the tangent drawn to the curve at a point decreases, and hence the slope of the tangent decreases as the time advances. So we can say that the velocity decreases as the time advances according to this curve. Hence, the acceleration according to this curve obtained in the position time graph is negative. Now let's learn how we can get the average acceleration in the position time graph. This is a curve we obtain in the position time graph according to the rectilinear motion of a particle. Now let's take two instants t1 and t2 on the time axis. The corresponding points on the graph on the curve are p1 and p2. Let's draw the tangent to the curve at point P, and let's draw the tangent to the curve at point P1 and point P2. This tangent makes an angle theta 1 with the positive time axis, and this tangent makes an angle theta 2 with the positive time axis. So the instantaneous velocity corresponding to point P1 is the tangent of the angle theta 1, and the instantaneous velocity corresponding to the point P2 is the tangent of the angle theta 2. The instantaneous velocity at t equal to t1 is equal to the tangent of the angle theta 1, and the instantaneous velocity at t is equal to t2, t2 is equal to the tangent of the angle theta 2. Hence the change in the velocity over the interval from t1 to t2 is given by delta v is equal to the instantaneous velocity at t equal to t2 minus the instantaneous velocity at t equal to t1 is equal to the tangent of the angle theta 2 minus the tangent of the angle theta 1. The interval delta t is equal to t2 minus t1. Hence, the average acceleration A average is equal to delta v upon delta t is equal to the tangent of the angle theta 2 minus the tangent of the angle theta 1 divided by t2 minus t1. Thus, this is the expression for the average acceleration of the particle in the position time axis over position time graph over a given interval. However, we get no information about the instantaneous acceleration of the particle in the position time graph. Hope all the videos related to the position time graph will be very helpful to you. The velocity time graph will also supply us with load of information, and we'll see that in the next video, and just wait for that. Sit tight. Thank you.